Hello everyone and welcome to today's webinar on how you can transform data into value with ITOM, IoT and MetricBase. My name is Nora Ottesen-Rinnen and I will be your moderator today. I am managing the marketing here at the Fujitsu ServiceNow practice and I'm excited to be introducing to you this session today. In this webinar, we will demystify the product MetricBase from ServiceNow and how it can be used to produce real value. Today's speaker will be our own ITOM expert, Alexander Ljungström. Before I hand over to Alex, I have a few practicalities I would like to cover. This webinar is scheduled to last for 1 hour with a Q&A session in the end. You will all be muted throughout the webinar to avoid any interruptions. If you want to ask questions, please submit these by using the selection called Questions in the menu on your right side of the screen. We will do as many questions as possible within the time frame in the end. If your question is not answered, we will contact you with the answer after the webinar has ended. Within the next days, you will receive an email with the slides and a recording of this presentation. So Alex, the floor is yours. Looking forward to learn more about ITOM, IoT and MetricBase.
Thank you so much, Nora. Good morning, everybody. From a very, very sunny Amsterdam today, which is nice for a change. Yeah, I'm equally excited to be here presenting today. I'm also very humbled by the amount of people who have shown interest in this topic and who has connected here today. Like Nora just mentioned, it will be recorded, so you can always send this out to your friends later via the YouTube link. Now, it's quite funny, on my way here to the office today, where I'm broadcasting, I actually interacted with 2 sensors. So first I rented a bike from one of these, automatic bike stands, if you know. And then finally, I bought a bottle of water at one of the stores here. And there was a fridge and there were sensors there. And this is exactly what we're going to talk about today. IoT, sensors, and big data. Now, before I get started with the topic at hand, there is some practical information I as well like to share with you. First of all, I do encourage you to ask as many questions as possible. And last but not least, this product I'm about to present today, MetricBase, it is a fairly new product. It does exist some information about it, for example, on the documentation website and at ServiceNow and so forth, but not too much. And that's basically the background why I wanted to arrange this here today. But by doing so, it also means that some of the content here today is, let's say, speculative, or it's something which I have found out via basically researching a lot on my own. So I just like to add that as a small disclaimer. Now, so in today's sessions, what we will cover then is metrics and time series, because that's very important to know, and of course MetricBase and how that relates. Hopefully you can also then know when to use it and for what. I'd also like to speak a little bit about a product called operational intelligence, and then of course machine learning, and how to get started with all of this, plus connecting it to IoT. Hopefully we will, well, not hopefully, we will have time for a small demo in the end as well. Now, I work as the lead for our ITOM department in Fujitsu, and to my help is my wonderful colleagues, and across Europe we are now almost over 25 people, I believe, that only specializes on ITOM. So I just like to make this small promotion before we get started with the actual content. And me myself, Alexander is my name. I was previously working at ServiceNow in their ITOM team, and it is a topic which I am very, very passionate about. I really enjoy, let's say, taking complex topics and making them more simple. And equally, I sometimes have the tendency to make very simple stuff overly complex. So it doesn't always work in my favor. Now, with all of that being said, let's get down to the nitty-gritty details, shall we? So let's start off then with MetricBase, because I don't know how about everybody on the webinar, but this is something which we have heard about quite a lot. It already started in the Kingston version of ServiceNow, and that was roughly 2-3 years ago, I believe. It was properly presented at Knowledge 17, but since then it hasn't really been that much information about it. And I think it's a shame because it has so much potential, and I've been spending the past months here deep diving into MetricBase, and it really is a wonderful piece of technology. But in order to understand MetricBase, we first need to understand the purpose of it. And what better thing to start with than time series data? So by the way, I am not a data scientist. Mathematics is not my strongest point. Me and my mathematics teacher in school when I was younger, we were fierce enemies. So if there's any data scientists out there today, then yeah, you probably have better insights than I do. But time series data then. What is time series data? Well, really what it is that data generated sequentially in intervals over time. And here you can see two examples, single and multi. So a single point of time series data might, for example, be a temperature in a fridge measured every minute, and you retain those measurements for 10 days. You could also have a multi-dimensional time series data. So for example, temperature for all the fridges in a particular outlet, let's say, and which is collected every hour and it's retained for an entire month. So you can basically combine a lot of these time series data sources. Some other examples here, which time series data fits quite well, is for example, disk space usage over time. Disk space usage is a classic thing, especially in IT operations, and I'm sure most of the people here recognize it. So in a time series example, we would then measure the disk space usage, for example, every minute. Then we could also have in other sectors, such as blood pressure over time. For example, if I am helping my father with his computer problems, then yeah, you could definitely measure my blood pressure over time. But you could also have other things, such as chemical levels in water or other type of sensor and IoT data. And you see a small graph here to the right side of the window, and that's a good example of such time series data then. Now, to follow this up a little bit, because this is really important, when we speak about MetricBase, then we need to have a solid foundation of what is the actual time series data. So let's first speak about a series then. As I mentioned before, it is simply an ordered sequence of numbers. And numbers, they don't really have many properties. The only property a number has, apart from the value itself, like 1, 5, 6, etc., is first, next, previous, last. So am I the first number in a list? Am I the next number? The previous number, and so forth. So when we speak about time series, a number doesn't really know that it's part of 1 week or 1 minute or something like that. It is an abstraction that we humans use to describe something, time that is. So from a perspective of numbers, they don't really care whether they are put in a timeline or not. They are just numbers. But here you can see an example of such a series. So 3, 10, 12, 13, etc., etc. And this is pretty popular in data science, especially to play around with quite a lot. And there are different methods then when we look at this data. So there are different methods of, let's say, predicting the data. So if you have many numbers, you would like to know what would the next numbers be. So for example, this can be used in financial forecasting or in operational intelligence and a lot of other contexts. And there are different methods of doing these predictions. A very, very simple method is known as the naive method, and that's basically when the expected point is equal to the last point. So in this case here, if you would take this series and we would apply the naive method, then it would mean that the next point would be 12, because yeah, the previous one was 12 here if we look at the series. And I realize this is a little bit technical right now maybe. So for those of you who are perhaps in a non-technical role, don't worry. It's still valuable information throughout this webinar, and I'm trying to keep it at a good level between technical and non-technical. So the power of time series is really to observe and to predict. And whenever we do forecasting in whatever field it is, may it be weather, financial, or operations, or IoT, then forecasting really is simply estimating values that we do not yet know based on the values that we do know. And the values we know are often then referred to as observed, while the values we forecast are referred to as predicted. And this is very classic, especially in data science then. So what really MetricBase often does is that it takes a lot of these type of time series, and we try to make various sorts of predictions. Not always, but very often. And here you can see a very, very simple modeling example of such a prediction. Here we see the predicted value of y, but we see the observed value down here, for example. So we always try to do these type of predictions with different methods, and I will speak about this more later when we touch a little bit on algorithms. But this is important to understand because this is in essence what MetricBase is about. So various series and time series. But it comes with some challenges. So to set the stage here a little bit, what we are observing, at least now, the year 2019, is truly a data explosion. Like I mentioned, on my way here, I interacted with 2 different sensors, and that's just a short bicycle ride to work. But as a society, we generate more and more and even more data or volume then. And this comes with a set of challenges. Because when we have all of this data, then storing that data becomes quite tricky. Sure, if you only have 1 or 2 sensors and you're measuring things every minute, then you could store that data fairly easily. But if we speak and scale this up to 10,000 sensors spread out over different countries that every minute is going to report data, then to store that data is very, very complicated. And this brings me to point number 3 here, that retaining and accessing the data is also quite complicated. So historically, what happened here is various companies, they invested a lot of money in building up huge databases, employing various types of DBAs or database administrators, and it's just very, very expensive to maintain this. So this is really the challenge that MetricBase tries to address them. And here is some what I thought pretty fun information. So for example, by the year 2025, it is estimated that, on planet Earth at least, we will generate 90 zettabytes of IoT data. And I don't think that number, it doesn't really reflect how huge amount of data that is. I read yesterday night a comparison. So if we take a zettabyte, and if we would take every megabyte to be a kilometer, just for people here to grasp this, so every megabyte is a kilometer in a zettabyte, that would mean that we could go to the moon back and forward 1,300 times in 1 zettabyte. So it's a huge amount of data. And this, by the way, comes from a Forrester report, so this is not just my speculation. 30% of all of this data is estimated to be consumed in real time. So it's not a matter of looking back in history, but really acting and responding in real time or as close as possible. And already today, every person in average have 700 to 800 digital interactions per day in one way or another. So you can see this huge data explosion and just what pressure it puts on the infrastructure, on staffing, and how to use this data. So what is then MetricBase? Now, MetricBase, as I said, it's a fairly new product from ServiceNow. It is a separate product, but most likely you will hear on it in the context of IT operations management. And if we just speak about the functionality of MetricBase, starting from the left side, it's really about collecting all of this data I just spoke about, retaining it in a meaningful manner, also being able to analyze it, but furthermore, act on the time series data. And when I say act, it could be really anything, and I will speak about that more later. Now, we also can connect all of this data to reporting, especially in ServiceNow, so you can combine all of this data with, for example, performance analytics and other various types of reporting functionality. Then we also have the ability to capture various types of events, especially from sensors and IoT devices. And MetricBase also comes with a pretty rigid and solid API. And that's quite important, especially when you're dealing with sensors and IoT. And last but not least, triggers. And that's where you often do the acting part. So when the data looks in a particular way, you want to take some sort of action then. So how do customers and organizations typically apply MetricBase then? Well, the usage here is definitely that MetricBase, starting from day one, simply integrates with the rest of the ServiceNow ecosystem. So practically what that means is that you can bring in the world of time series data, sensors, and IoT to the ServiceNow ecosystem, and you can then connect it to every little part in ServiceNow, may it be incident management or alerts or maybe orchestration and remediation and so forth, or reporting is another good example. I also spoke earlier about just how tedious and cumbersome it is if you would develop this data storage yourself. So this means that ServiceNow has the infrastructure hosted, so you don't need to care at all about really the hardware behind storing all of this data. But most importantly, what people use MetricBase for is to build their own type of applications. So as you might very well know, ServiceNow is a platform, and you can of course build applications there. But with MetricBase, you can build specific IoT and sensor data related applications. And now to the I would say confusing part. So if you go out, especially online or on the community website, and you start reading about MetricBase, MetricBase is actually two things. MetricBase is, first of all, an application in ServiceNow, but more importantly, the database that ServiceNow has in their data centers where they store all the data, that's also referred to as MetricBase. But the correct name for that database is actually Clotho. And that's what you see on the right side here. So Clotho is then an own proprietary database by ServiceNow. It has nothing to do with the database that you normally would use in your instance. So for example, when you create a new incident, it is stored in the ServiceNow database. But when you are capturing time series data and using MetricBase, it is stored in your own Clotho database. So it's unique per customer or organization. So there's no shared databases at all. And furthermore, it is built on a NoSQL approach, simply because, yeah, if we would look at, let's say, MariaDB or MySQL or any one of these relational databases that the normal ServiceNow platform uses, it's simply not cut for the job, and you will get a lot of different performance issues. So this also means that it can scale. You can rapidly move from 100 sensors to 2,000 sensors, hopefully without any interruptions or any impact on the performance. And this is very important to know. The reason I'm mentioning this is when you have a problem with MetricBase and you start Googling, or if you search for it, as I mentioned, then some people might refer to the MetricBase application in the ServiceNow platform, and other people will refer to the backend database. And for the sake of this webinar and going forward, I will call the backend database Clotho. So I hope that makes sense. Now, the power of MetricBase is these triggers. And the triggers is also an important part to grasp. So what is really a trigger then? Well, a trigger is simply whenever some sort of threshold is reached or when a prediction is met, we want to do something, like create an incident, or maybe even turn off. If you have like an industrial controller which controls water flow, maybe you would actually like to turn that off, for example. So these triggers can be created in MetricBase, the application, and you can define these various type of triggers. And I'd like to speak a little bit about how this might actually look. So in this example here, so from this time series data, if we would then take temperature as an example, we could then choose to model temperature data from the past 30 minutes. We could add a confidence score to it. We could add a trend. So will the temperature go up or down? And what is the threshold and time window? And I bet right now this doesn't make any sense at all, but don't worry. To illustrate this example, here is a graph in front of you. It's a pretty maybe weird graph with a lot of temperature fluctuations, but let's use it as an example. The blue part of the graph represents the historic data, and where the blue part ends and it transitions into orange, that's the predicted data, right? So that's the prediction. It has not happened yet. It's the future. So we can then define a time window and say to MetricBase that, all right, try to model, let's say, half an hour now in the future, or 2 hours, or like in this case, 5 minutes. So let's try to predict something for 5 minutes in the future based on the historic data. And the trend in this case, we would say, well, we want to try and predict the upward trend, meaning the temperature would rise. And we also have a threshold here. So let's say we set the threshold to 27 degrees. That would mean that in this prediction, 5 minutes in the future, if within that prediction it would hit 27 degrees, we would like to do something. Now, the reason this is very, very powerful is because if this is an accurate prediction, it means that we can actually start working on fixing this issue before it has become an issue. Because if you remember here, right now is the blue line and the future is the orange line. And if we already can start creating an incident or act upon a prediction, it means that we can be way, way more proactive then. So this is a good example of what a trigger really is. And I will later actually show this as well. So the API then. Well, the API in MetricBase is also quite important and powerful. I'm not going to go into too much details here, but essentially the API here, you have the possibility to pull time series data. So maybe you have external systems, or maybe you have suppliers, you could have data warehouses, and you want to access this metric data then from the Clotho database. Well, you can do that via an API, and you can also then transform the data in various ways, like average and sum and so forth. But also, which is more importantly, you can post data via the API. So you can have various types of sensors or any type of program really posting data through the API via standard REST. And here you see an example of such a post request to the right here. And there are a few things I like to highlight here. The subject, the table, and metric. So the subject here is really a sysid, and the sysid then exists in ServiceNow. So what do we want to submit metrics for? And then of course to which table and what type of metric. In this case it is water chloride level. And then of course we have the actual data here in the values. So the timestamp and the actual value then. So you can now kind of see how this forms a time series, especially over time then. So that's really what MetricBase from a very, very simple perspective is. And this will make a little bit more sense as I go through the demo here, hopefully. But MetricBase standalone, it's a good product. You can use MetricBase to build your own IoT applications. You can process large amounts of data via the Clotho database at ServiceNow, and you can work with these type of triggers and so forth. But the true power, at least in my opinion, comes when you combine MetricBase with another product from ServiceNow, which is called Operational Intelligence. And this is often the most common scenario, by the way. I don't think there are many organizations, if any, that is only using MetricBase without anything else in ServiceNow. Maybe there is, but I would be surprised. So operational intelligence then, why is that so important, especially in context of MetricBase? Well, we need to first speak a little bit about the nature of monitoring in order to determine that. So what you see in front of you here is, from the left side, raw metrics, then we have events, then we have alerts and incidents. And depending on what type of tool you use, especially in your infrastructure, you will tap into different areas here. So if we look at raw metrics, what that really is simply, for example here, CPU average load, input output, RAM, etc., etc. And those are the raw metrics. Those often comes from the operating system, for example on a computer. But it could also be raw metrics from sensors. Is it on, off? What is the water flow? What is the XYZ, etc. Then we have events, and this is often where monitoring tools are acting. So if we take the classic in especially in normal IT operations and monitoring, like SolarWinds and Nagios, they generate events which are containing the raw metrics. So in the events, you would see the CPU load or the memory consumed, for example. And this is where humans come into the picture then. So in these monitoring tools, and even in ServiceNow, let's say in event management, people manually define various types of thresholds and rules. And often they look, like the example here. So if X is bigger than Y or smaller than Y and so forth, then we want to create an alert. So for example, if disk space is over 90%, then create an alert. Or if the CPU is over 95% for 30 seconds, we want to create an alert because most likely something is wrong then. Then we often also then, based on those alerts, either manually create an incident or automatically create an incident. And it's often on the incidents that we attach customer SLAs, and we really work with fixing the issue and perform the root cause analysis then. And this is something really all monitoring tools are doing, even ServiceNow, although that's not a monitoring tool, it's also following this, let's say, model here. And if you're using SolarWinds, maybe you are then creating incidents in ServiceNow via an integration, let's say. But there is a problem here. And the problem is that it truly only reflects the as-is situation. So if we take, let's say, the CPU or disk space, and we get an alert, before a person actually has started working there, and especially if it's an incident, then yeah, the issue is already there. So it's firefighting. It's not being proactive, it's being reactive. And there's nothing wrong in this, of course. We use the tools that we can use, and we try to mitigate as much as possible. But what if we could do it a little bit differently? This is where operational intelligence come into the picture. So the background really is, how can we monitor data more intelligently? And it doesn't need to be data for CPU or memory. It could be any sort of data really. Like I mentioned before, chemical levels, blood pressure, various sectors, retail, manufacturing, and so forth. But operational intelligence then, well, what that really does is, operational intelligence is a product from ServiceNow that has built-in machine learning, and this is automatically activated. And it applies different types of algorithms on raw metrics and sensor and time series data. And it really only has one mission: to detect anomalies. And this is also known as outlier detection or statistical deviations and so forth. And this is something, these algorithms have existed for quite some time. The first ones of them were probably created 20-30 years ago. It's also very common to use them, for example, in finance business, fraud detection, or know your customer. You might want to look at transactions if you're a bank, if something weird is going on for money laundering perspective and so forth. So anomaly detection is not a new concept, but it's fairly new in the world of at least monitoring and sensor data. And what operational intelligence then does is, if you remember from this series, which is just data points of numbers, ServiceNow and operational intelligence looks at these data points and it assigns anomaly scores. So to the right hand side here, you can see quite few examples that on the top we have time and we have some sort of metrics, and then we have a spike, and that is an anomaly of some sort, and that would then get an anomaly score. The anomaly scores are between 0 and 10. 0 means that it's completely normal, meanwhile 10 means it's highly deviating, it's very abnormal. It is an outlier. We also see a few other ones here, examples of anomalies. So what can we then do with these scores? Why do we need these scores? Well, first of all, we can act on these scores. Like I mentioned before, we can already start creating various types of actions when we see these anomalies. But we can also put them in anomaly maps or a better context. So maybe you would like to look at a certain set of CIs or an entire business service, and you would like to see exactly when has there been anomalies and when hasn't it been anomalies. So the value is not only always in real time, but it can also to go back in time and make some sort of assessment or analysis then. And operational intelligence really extends the mid server from ServiceNow with an actual brain. So for those of you who have seen a few other of my previous webinars or who is working with IT operations, perhaps you know that the mid server, at least historically, is pretty stupid. And what I mean with that, it contains no logic. It's just a gateway. But when you start using operational intelligence, the machine learning part and the anomaly detection is actually happening on the mid servers. And furthermore, you can combine all of this machine learning and algorithms with your own models and testing. So essentially you bring data science a bit closer to engineering, and that's a very powerful tool. Now, there is a misunderstanding here often that operational intelligence and MetricBase will all of a sudden tell you what's good or bad in your system. That's not the case. It's only us people who can often tell whether something is good or bad. But what operational intelligence does really well is tell you what is normal versus not normal. Sometimes it means that when something is not normal, it is bad, but it can also sometimes mean that it's not a problem, and that's known as a false positive. So the algorithms then, I'm really not going to deep dive too much here, but yeah, I like algorithms. So for those of you who are geeks and nerds in this, it's an unsupervised machine learning algorithm, which means that when we apply operational intelligence, we don't need to tell it what to look for. It learns by itself. So the more data you feed, may it be sensor data or from computers, then the better it becomes, basically. The algorithm also appears, now I don't know this because I haven't investigated the codes or I don't work at ServiceNow, but it appears to be a non-parametric one. And what that means is, yeah, we don't make any assumptions. When you work with algorithms, sometimes it can be good to make assumptions. So let's say we would only work with temperature. Well, we can assume that the temperature will never be above 200 degrees Celsius, for example. But in ServiceNow, we don't make any assumptions because the data can really look in any way, and the data can be from different sources. So this actually enables the algorithm to be very broad and learn many different things. My guess, and this is a guess, emphasis on that, is that the algorithm is probably, it's called DBS scan or DB scan, density-based spatial clustering of applications with noise. So what happens then when we receive an anomaly then? Well, as per the example here, we have a time series and then we have a spike. Well, what ServiceNow then does is that we assign an anomaly score by operational intelligence and we create an anomaly alert. So we actually create an alert saying that, hey, something is going on here. This is not normal. And depending on how severe that anomaly score is, so if it is, let's say, above 8, which means it is pretty different from how the data usually looks, then we can actually promote this anomaly alert to a normal traditional IT alert. And it would then come up in your normal event management module. And from that IT alert, we can do various types of things, like applying remediation or connected to incident management and so forth. So this is a very powerful tool to work with anomaly alerts, and it really gives you a better type of insight than just working with normal monitoring when you only react all the time. But here, maybe you would get an anomaly alert and then 5-10 minutes later, you would get an actual alert about the disk space being full, let's say. Right, so operational intelligence then, because this is a somewhat technical webinar, what do you need to get started then? What are the basic requirements? So first of all, when we want to track something and report data on it, we would do that as CIs. So if we would track computers or servers or network switches, those would need to be CIs. And similarly, if we would like to track something with sensors, that would also need to be CIs. And that means we need a CMDB first. Doesn't mean that we need a perfect CMDB. It doesn't need to be a huge, extensive CMDB, but at least we need to populate the CMDB with CIs that we want to measure on. We also need event management from ServiceNow. Yeah, event management is another part of IT operations. Then we need to define something known as connector definitions, and that's basically what metric we want to pull, how often, and from where. So for example, SCOM or Azure or AWS. This comes out of the box, but you can also write your own connector definitions if you want to tap into metrics somewhere else. You might also need, depending on the use case, to write some connector scripts, basically transforming the metrics to be in a format that ServiceNow understands them. And then you would need a connector instance. So a connector instance is an instance of a connector definition, and you can have multiple instances of the same definition. So let's say we are fetching metrics from Azure. I might have 3 connector instances to Azure, 1 instance per subscription maybe, or 1 instance for various metrics types and another instance for other metrics types. Then you do need to make the mid server a bit smart and intelligent, so you need to enable operational intelligence on the mid server itself. It's just a sys property or setting. And then last but not least, you need the MetricBase database provisioned, or the Clotho database. And this is the database that ServiceNow creates for you. And that is the database that your ServiceNow instance connects to. On the right side, some bonus here is that if you want to use sensor data and you want to apply the machine learning, you need to send it via the mid server, because that's where the machine learning takes place. If you send it in other ways, so let's say directly to the Clotho database, then you won't get machine learning. And in order to do this, you would need to configure the mid web server extension. So obviously I'm not going to go through how to do all this today, because that would take too long time. Right, so how does this connect to the world of IoT and ServiceNow? You might see where I'm going with this, and yeah, I am not an IoT expert as such. I'm very passionate about it. But if we look at a simple architecture here, very simple. To the left-hand side, we have various types of machinery maybe that we have sensors on, and that can measure, let's say, flows, water flows, for example, or different types of levels. Maybe you have levels in an oil tank, or temperature, like the example I gave. And this is often, especially if you work a lot with IoT, facilitated via a broker. Yeah, I'm not going to go into details what that is, but an MQTT broker. So for example, RabbitMQ or Kafka. And what you then need to do here is, from this broker, either directly in the broker or via something known as a pusher, you would need to push this sensor data with a timestamp and a value over REST API to the ServiceNow MetricBase API or the mid server API. The mid server API is if you want anomaly detection and machine learning on it. So this is a good use case of how to bring in the world of IoT into ServiceNow. And to integrate it even further then. So what would you need? Well, first of all, you need a broker with MQTT support or some sort of IoT platform. For example, Fujitsu, we have our own IoT platform known as Iconics. You would then need to take these MQTT topics and basically convert them to a REST message, for example, by a webhook. And the REST message is what you would push to the MetricBase API or the mid-server API. And as I mentioned, you need to have CIs for the devices that you're measuring data on. So for example, industrial appliances. Therefore, you need also here some sort of CMDB in place. So where do you take it from here then? And this is what I'm going to show now in a demo. Well, you can definitely integrate it with other core processes. And so incident management is a perfect example, but also alerts or orchestration. So by orchestration, you could actually turn things off or act upon it in various ways. You could report on the metric data, and this is really what this webinar is about. You can take action on this metric data, and you can turn it into actual value then. So with that being said, let's do some quick demos, shall we? So what I'm having here in front of me is our Fujitsu's IT operations instance. And we have, well, not we, but a good colleague of mine have created here a IoT demo about fish tanks. I know it's maybe not the most common things, but fish tanks, they have quite a few interesting stuff. So here on the right side, we can see that we're actually measuring here water acidity, water carbonate hardness, water nitrate levels, and water temperature. So if we would take water temperature here, we could actually then create a time series chart. And this is all coming from sensor data, and it is stored in the MetricBase database or the Clotho database. And by using this data, if you remember from the beginning, I said that metric series, you can combine multiples of them. Well, here we see that we have 4 fish tanks, but maybe we would like to see in the past hour, what is the average temperature in all those fish tanks? Well, here we have the average temperature, and we can also select here to zoom in on a particular part and look even closer. And as I mentioned, we can then, because we're measuring this data all the time, we can create various types of triggers. So if I type MetricBase here, so this is the application MetricBase. Here is where we define different types of time series then. So here we have actually defined, as you can see, water hardness, water temperature, and so forth. And you can define this for anything. Here we have fish tanks, but we also have Linux servers and so forth. Now, what I want to show here is the trigger definitions, just quickly, and how this might look. So a trigger definition then is when we receive sensor data, we want to do something with it. This is a good example, a linear predictor trigger, and that's what I explained earlier. So it looks like this. We would then call this something, demo trigger upward. We would apply it on the fish tank table, u_fish, I think. Right here, fish tank. And we would select a metric. So let's take temperature as a good example. So here we say, all right, so let's go back in the data and use that. We have here days, hours, minutes, and seconds. And for this, we want to go back 30 minutes in history. And we want to add a confidence level. And this is a little bit tricky to explain, but I'm going to try and do my best. So the confidence level is how confident are you in this data, or how confident do you want the prediction to be? If you would choose 100% confident, that would mean that the data needs to look very, very, very similar all the time. Meanwhile, if you had a very noisy data where it goes up and down and in different directions, you would have a slightly lower confidence level. But let's take 90% confidence level. And here we would say the actual temperature. So let's say 27 degrees. If in this prediction, the prediction would say that, well, we predict this to be 27 degrees, then we want to act on it. So I will save this. Boom. And now here I would need to insert a time window. So how long in time in the future do I want to try and predict? Well, let's say 30 minutes. So in this prediction then, we would say that, okay, try and predict 30 minutes in the time in an upward trend based on the past half hour. And if within this prediction we would reach 27 degrees in temperature, then we want to do something. We want to create something, like an incident. So this is a good example of a trigger. Another good example is the anomaly alerts. Yeah, leave that. So here you can see anomaly alerts, and these have just been created here. So this one right here is actually an alert created automatically by operational intelligence. And from this alert, we can then also automatically create, for example, a normal IT alert, right? So we have then promoted this alert to become a traditional normal alert, which people then can work with in various processes. In this case, we have already now created a work order. And in this work order, we have assigned the work order to an engineer to go out on a location and have a look at this fish tank. Hey, why is it acting strangely? We are not expecting this right now. So this is really predictive maintenance and predictive analysis in its essence. Here we see that the water temperature have exceeded the threshold. And the way we also can determine this is via the anomaly map here. So if you remember before, I spoke about all of these anomaly scores that we are measuring. They are actually put in a context. So if we take this one here, the fish tank here, we see that, okay, in the water temperature here, most of the time it looks good, but hey, something has actually happened here in a span of 30 minutes. And if I click here, I can then instantly get up the values. Now, here we see that we have various types of values, but essentially what this is telling us here, the blue line here, that is the actual temperature. The red line in the top is the anomaly score. So you can see a clear relation here that when the temperature is not acting normal and it starts going down, we see that the anomaly score starts going up. And then it continues being up until something has fixed the temperature issue. Then the anomaly score goes down again. So this is all predictive analysis and IoT in a very, very good example in my opinion. And you can use this anomaly maps for various types of purpose. Like I mentioned before, in this case right here, we are creating work orders, but you could create incidents, you could do orchestration, really any type of action. So this was really shortly about what MetricBase is. This application with the fish tanks that we're showing here, it is an application we have created from scratch with the help of MetricBase, and this is typically how we would use MetricBase. And the reason we are getting anomalies here is because we're using it with operational intelligence. Yeah, so in my opinion, this is something which is very, very useful, especially when we're seeing just at how much data is being generated. And that was really all I had to show in terms of a demo. I see we have 5 minutes left. Nora, have we received any questions?
Hi, Alex. Yes, we have received a question. I'm going to read it up to you now, and you can answer it. The question is it possible to do transformation on metrics input before storing to Clotho, like in MetricBase reports, i.e. do a counter value or delta time between data points?
Right. Yeah. So it's not only raw data that you can do this with, because you're sending it through ServiceNow to your mid server. It actually means that you can intercept the data and transform it in some sort of way. Now, I would question a little bit the use case around this, because often the transformation takes place. It's a little bit upside down, but yes, you can do it, and maybe there is a good use case for it. So the answer is yes, you can.
Thank you. Yeah, there's one more. I'm just going to read this, and if there are more questions coming in, we will answer them on email. The second question here now is, hi Alexander, is it possible to do something similar with the triggers as with the Anomaly and the promotion rules to create tasks? I mean, in the triggers, the functions allow to create an incident or similar?
Yeah, excellent question. I basically forgot to mention that part. So these triggers, what actually happens is, if we go here, we actually define. So I showed before the trigger definition. So okay, is it going to be an upward trend or downward trend? Is it certain thresholds and so forth? But then what you actually do with that trigger definition is you connect it to something known as the flow designer. So you can have various types of flows basically kicking in. Here are a few examples of flows, like creating an incident, create a work order, and so forth. But definitely, I think if I understand the question correctly, then yes, from that trigger, you can act upon it in any sort of way, and you do this via the flows then and the flow designer. Good question. Right.
Okay.
Nice.
Thank you, Alex. So this was all we had for you today, and I hope you all found this session useful. As already said in the beginning, you will receive an email with link to the presentation as well as the recording. If you want to get in touch with us regarding ITOM, IoT, and MetricBase, please feel free to contact us. We frequently host webinars related to the ServiceNow platform, so make sure you follow us on LinkedIn to get the updates, or visit our webpage where you can sign up for our newsletter. I will end this webinar by thanking you, Alexander, for this great webinar, and I will also like to wish you all a great day. Thank you very much.
Thank you all, everybody. Have a nice day. Bye-bye.